On today's Maker Mashup, day 5 of our 3D printer build. Okay, so we're at day 5 of our 3D printer build, and today we're going to be focusing on the electronics and the nozzle. We're going to get that all set up, and at the end of it, we should be ready to kick off a test print and start calibrating this printer. The only thing that we're not going to cover in today's video is going to be the actual setup of the SKR. The control box will go here, and that will have the SKR motherboard in it. And what we're going to do is do that as a separate video because that setup really is pretty lengthy. And we want to get everyone to see that we've got a finished working printer, and then we'll cover that very small piece of the electronics afterwards. So the plan is today, let's get the electronics in here. We're going to get our nozzle in. And if we have enough time, we're going to kick off a test print just to show the printer working. And then in a next video, we're going to cover the actual SKR setup. And that one will be pretty detailed. So let's get to work. So I'm excited for today. We're going to review our parts. Then we're going to get the end stop set up. Then we're going to follow that up with working on the power supply, getting that all installed. Then we're going to do the extruder and the nozzle, and we're going to do a lot of cable routing. Really important you spend a lot of time on that area. And then we're going to install the bed and the glass. We'll hook up the wires to the main board, and then we should be ready to print a calibration cube. So let's go over the parts for today. We're going to need one SKR mainboard, and I suggest checking out the other video that covers the setup of that mainboard. We're going to need one 350 watt power supply. That's a 24 volt power supply and a power switch. The power switch is optional, but I really recommend that for safety reasons. Then you're going to need one 50 millimeter blower fan. That's going to be our part cooling fan. And then we're going to need one 40 millimeter muffin fan, and that's going to handle the cool end of the hot end. Next, we're going to need 3 end stop switches. We're going to have to solder those ourselves. We're going to need one geared extruder. You can use different extruders, but the geared extruder, I think, has some really great performance benefits. And we're going to need a stepper for that extruder. And then we're going to need one 24 volt nozzle with the heater cartridge and the thermistor, and an assorted wires and connectors for getting the end stops and everything else all together. We'll have a complete parts list available and a Google Doc at the end of this video, and we'll go and update the other videos in the series to point to that same document as well. Then you're going to need some various zip ties and screws to complete this. And again, that'll all be included in the parts list. And then we had some heat bed woes when we were doing the last minute install of this, but you're basically going to need a 214 millimeter or 220 millimeter heat bed, and it has to be a 24 volt heat bed. So everything you buy here part-wise is going to need to be 24 volts. All right, so let's get to work on the rest of this. So let's start by soldering our end stop switches. So each one of these switches operate in either a normally open or normally closed fashion. The way that we have these set up is that you want to solder this to the common lead and then to the one that is normally closed. So when the switch is activated, it will interrupt the signal to the main board and indicate that you're on the end stop. This is actually the preferred way that this should be set up, and I've gone ahead and the firmware is configured that way as well. So if you download that from our repo, you'll find out that that is already set up for you for the C201. One of the things I use here as a trick is that I buy these leads already pre-made. So they're at various lengths, and links will be to these in the description. While you can use regular wire and crimp these yourselves, I find it's much easier to buy these leads halfway completed, and then all you have to do is break off the ends, solder them to the switch, and then plug them in. Now another trick here is that these switches are Actually, I think around 2.5 millimeters. So a 3 millimeter screw is a little tough to get through here. One of the things that I like to do is just take these screws and you put them in before you try to get them attached to the end stop mounts themselves. So it's a little difficult pushing them through here, but you'll find with a little bit of force, you can force an M3 screw in there, and it makes it a lot easier when you're connecting it to the printer. The first one we're going to install here is going to be to the X-axis. It's important that you're careful not to break or force any of these 3D prints when you're installing this, because if you crack this, then you have to go ahead and uninstall all those pieces and reinstall them. You can see here that this particular model I chose has a channel, so you can route your cabling through this channel. Now, I did mention earlier that cable management is really a big key with your 3D printer. You'll have to go through here, and all of these leads need to make sure that you have them wired properly. For the X-axis, they'll need give to go up and down, but ultimately you need to make sure that you test all of your wires and keep them as contained as possible. For the Y-axis, you're going to need to attach the end stop to the bracket itself, and then attach the bracket to the frame at the back near the stepper here. Then you just want to make sure that you've got a good click and you're all set. The Z-axis is slightly more complicated. You can see here that we're using a wrench instead of our typical screwdriver because of the limited space that we have here. Now, once you install this, you may have to move it up and down to get a good position on where your bed needs to level out at. So it's good to get this into a decent position, but then later on, absolutely move this up or down as necessary, so that way you're pretty close to your bed when you get to the homing of your 3D printer. Now we're going to get the mainboard cover ready. This is a knurled threaded insert. You just use a soldering iron and push these into place, and if they get stuck, you can use a screwdriver to pull the soldering iron out, but for the most part, you just press them in, and then once they're in, you can go ahead and mount your mainboard. Just be careful because these inserts do get pretty hot. Once you're ready to mount your main board, you can see there all 4 of them are in place, and these are just M3 screws, so you'll just go ahead and use an M3 screw to mount your main board. There is a tab on one side of this, and it is critical that the steppers go near this tab when you mount this, because the tab is used to hold the back in place with the screw once you get the main board installed. Now, the knurled inserts really are an optional piece, but I prefer them because I think it makes a much more solid connection with these M3 screws for your main board. Also, be careful not to over tighten any of this, as it could possibly crack your main board. They just need to be solidly in place. Now we're going to use some M5 screws and our T-nuts to attach the main faceplate cover. These just go right on the end of the printer here, and then your display is going to push into this. Now that we have this mounted, we're going to put in here our stop button. This actually presses on the reset button of the board. So if you ever need to reset your printer, it acts more as an emergency stop than anything else. You generally should stop your print in a traditional way, but if you absolutely need to stop everything on your printer, that button is going to reset the main board and stop everything. With the display in place, we're going to assemble the middle enclosure. This presses up and holds the display in place. And these are some specialty M3 screws I got at the local hardware store, and those sizes are in the bill of materials. The next steps in this project are going to require you to work with wiring with high voltage mains. This is electricity coming into your home, and in the US, this is 110 volts. However, much of the world runs on 220 volts, and the current in these wires can easily kill you. So please proceed with the remainder of this project only if you understand these risks and how to handle these voltages safely. If you're in doubt about anything or how your power works, consult an electrician or other expert in your build. Above anything, your safety is what's important here, so please proceed at your own risk. So Danny here is going to be installing the switch, and the wires for this are going to vary widely based on your location. So you need to consult the power supply documentation, your electrical documentation, and then of course the type of switch that you buy for your location. For us, the red wire here goes to the L on the power supply, which is the live or hot wire, and then blue is going to go to our neutral, and that yellow with a green stripe on it, that is our ground wire. But again, these vary widely, so it's very, very important that you make sure that you know what you're doing when setting these up and use the utmost safety and precaution when doing so. Make sure before you hook these up that you've put the switch into the plastic box that will hold the switch and cover up this electrical portion of the power supply. And also what we're going to need to do here is once you've got the mains voltage hooked up, we need to get 24 volts of power out of it. And these are 16 gauge silicone wrapped wires. I did knot them inside the box, so it's a little easier to assemble here. And what Danny's just going to do is hook up these two wires, one to the positive output and one to the negative output, black and red respectively. And this is now DC current going to the main board of your 3D printer. Once your wiring is complete, you're going to want to attach this with some M4 screws to the back of the power supply. This model is slightly different than the one that you'll download. I changed it before we assembled the final printer to include a way to attach it to the extrusion. Then you're going to want to attach the top bracket. Again, these are just M4 screws. And then M5 screws are the ones that are going to attach it to the extrusion. When you mount this, you're going to want to mount it directly below the control box that's above. And then this just mounts to the back of the printer. And you just attach it with these M5 bolts. So now we're going to move on to the extruder. Danny's putting the extruder gear onto the stepper motor here. This metal bracket that we used here came with some steppers, but there is a 3D printed one that you can make to use instead. And we just mounted this to the right hand side here temporarily until we got the nozzle done. So let's get started on the nozzle. This is your standard V6 style fan shroud. And what I've added here is an adapter from the 30mm to the 40mm. I feel like this provides considerably more cooling and the fan runs a little bit quieter. And if you really want to make it quiet, you can put a Noctua in there, which are very silent. So we put the fan shroud back onto the nozzle, and then we're going to mount it here to the carriage. These are just going to be M3 screws that we use to attach this nozzle to the carriage itself. This is all 3D printed parts, so be very careful when you're installing this. You'll need to drop a nut down in those little slots that are highlighted here. Once you drop those nuts down in there and screw this in, you want to do it evenly on both sides, and then it should hold that nozzle pretty tight. You're also going to want to, before tightening it up completely, make sure that your heater cartridge and the wires are pointing to the side like it shows here for Danny. You want to make sure that they're not pressing on the plastic piece for the part cooling fan. So you want to line that up before you finish tightening it up. Now we're going to put the part cooling fan into place. This just fits right on top of the carriage. And then the screw here, this is an M3 30mm, just slides right through there. And then you're just going to attach a nut to the other side and tighten everything up there. Only one screw holds this in place. So now it's time for a little wire management. What Danny's going to do here is we're taking all the wires as part of this carriage and we're going to group them together so that way we can make them as one long umbilical lead to the control box itself. So we're going to start here by just test fitting everything, but then after that we're going to put some zip ties on there and then we're going to wire wrap it. Then as part of this, you're going to want to make sure that your wires are not going to catch on anything. Generally speaking, the top is usually a safe place to put everything, but you just want to double check and make sure. Now that we're sure everything fits, We're going to tighten up the zip tie here and lock everything into place. And then we're going to go ahead and put a couple of more zip ties down the leads, just so that way we can make sure that they stay together, and then we'll begin wrapping them with a cable wrap. So we're doing the cable wrapping here, and you can see we just wrapped this around the entire set of cables, and you can notice that I did leave the zip ties in there. So these zip ties are only for while you're wrapping this cable. As soon as you're done wrapping the cable, then you're going to want to remove those zip ties carefully and be sure not to cut any of the wires. You don't have to have the zip ties in here, but I found over doing a number of these printers that it's much easier to wrap these if they're zip tied, at least for the majority of the length. That way they hold them together. You don't have them trying to expand or go all over the place. So it's a real easy way and a quick tip. Now that the electrical is done, we're going to measure the length of Bowden tube that we're going to need here. Now this is going to reach from that extruder, and it's going to go all the way down. And you're going to want to leave just a little bit extra than you think you need. And then you're going to want to insert one end into the extruder here. And you got to make sure that those press fit fittings are very, very pushed in, so that way you get that in as far as it will go. And then on the top of this extruder, you're going to want to do the same thing with the little piece of Bowden, and that acts as a relief for the filament. And then once that's complete, you do a quick little test fit with the filament itself and make sure it flows into the Bowden below easily enough. You will have to loosen up that screw on the side, given that this is a geared extruder. Now you're going to want to insert the other end of your Bowden into the nozzle. And in this case, same thing. It's a press fit. You just need to push it in all the way. It's not going to go down terribly far because this is an all metal hot end. Now that we've run that Bowden tube from the extruder down to the nozzle and inserted into the nozzle, our next step here is to just get the spool for our filament holder up in place. And this is just a 3D printed part and a couple of M5 bolts. Now we're going to build some knobs for our bed. These are the knurled threaded inserts, and these 3D printed knobs, we're just going to do the same thing and use the screwdriver here to pull the soldering iron out, and we'll make 4 of these knobs for the bed. So now we come to the infamous print bed. So we had a bit of an issue with this print bed from what we were originally going to install. Originally, I had what we thought was a 24-volt bed, or at least one that we could convert like we are this one to a 24-volt bed, but the vendor had manufactured it in such a way that it was 12-volt only. So we ordered a slightly different bed, but this one will work just the same. This print bed can be either 12 or 24 volts, and it comes in a 12-volt configuration. And what we're going to do here is unsolder this particular pad, and then we're going to resolder these 2 wires, the positive on pad 2 and the negative on pad 3, and then that will convert it into a 24-volt heat bed. Now, it's critical that you understand that if you install the wrong type of bed, there's a severe fire hazard, so it's critical that you match all the parts that you're going to install on your 3D printer to either be 12 or 24 volts, depending on what you specifically used as your power supply source. The one exception to that is the main board, and most main boards will support both a 12 and a 24, but always check the specifications of your main board before you install it. The SKR used in this project supports 12 and 24 volts. Once you have it unsoldered, if you have like we did where they had jumpered both 2 and 3 together through here, I just used a little solder braid to go ahead and clean this up. I just wanted to make sure that there was no residual solder shorting out this. So always good to make sure that you're cleaning up what you're doing here if you have to resolder these. So once you've gone ahead and removed the leads, then we can reconfigure this by soldering this onto pad 2 and to pad 3 with the positive and negative voltage. And now our 12-volt bed was converted over to a 24-volt bed. Now this bed here does not have an aluminum backing, so we're going to use glass, and that's going to be our print surface. Now that we have the bed all set and ready to go, we're going to use some washers here on the bottom. And what we're going to do is put into place the bed. It will go through those same holes that we drilled in the very first video. And with some washers and these nuts, you're going to put this on all four sides. And once you get them on all four sides, we'll be ready to get started on the next piece. Now we're on the final part. We're going to want to do all of our cable management. Start by running through all the different cables and running them up to the control box. You're going to have to go through each and every stepper and attach each wire. And then you're going to have to go through here and bring this all the way up to your control box. We use these, and I've linked them all, these little 3D prints that hold the wires into the track itself. These work great. Also have these other clip types, which are great for just holding larger groups of wire. You just go ahead and put them around the wires, and then after that, they're great for connecting wires to the extrusion, just like the heat bed here. These keep wires neat so that way they don't get in the way of any of the gears or belts, so that way everything is all smooth operation. So you can see here that we have all the wires looped through the control box, and now it's time to start hooking these up. We're going to start here with the main power leads. So these are coming from the power supply output. So these are our 24-volt wires, and they're going to go directly into the main board. It's very critical that you look here and make sure that you're hooking positive to positive and negative to negative. Always go back to the schematics, which are available online. If you go back to those schematics, you'll always know that you're hooking it up correctly. After we put the main power in place, now we're just going to hook up the EXP1 and EXP2 of the display. And these only fit in one way. So if you look at the board, they're marked EXP1 on both the display board and on the main board here. You just have to match those up with these ribbon cables. Across the top here, you can see we've got the X, Y, Z and extruders. So you're going to want to put in each one of the stepper motors for the extruders and those axes. Because the Z axis has two steppers, to simplify things, we use a parallel module here. And what this does is it more or less splits the signal between the two different stepper motors. Now we do apply a little bit more current to the Z stepper, which allows us to use the two steppers and just plug this into one port on here. Another option would be to use the second extruder for this. Some people use that, but we set this up with this module in mind. Now we just plug in the rest of our axes, and then we'll move on to the next step. Now we're going to install the heat bed wires, and if you look carefully here, you'll see that these two positive wires are next to each other. That's why it's very critical that you look on the way that the board is marked that you're installing these into, and then also that the wires match up. Normally, if somebody saw black and red, you would think the next pair of wires would be black and red, but that's not the case here. These are actually the two reds next to each other. Now we're going to install the heater cartridge for the nozzle. These wires don't have a polarity on them, but they do have a Phillips screwdriver. I'm not sure why the vendor picked flathead for one and Phillips for the other, but at the cost of only $20 for this board, and it works very well, I can't really complain. So get those screwed in, and then let's move on. Now we're going to put the thermistors in. These are what determine the temperature of everything. So TB is for your heat bed, so that gets plugged into your heat bed 1. And then the other wire here goes to the nozzle, and that is your other thermistor. And both of these are plugged in next to each other. TH1 will be empty because you only have one nozzle. This is the always on power, so this one goes to the muffin fan. Yes, the muffin fan. And make sure the powers are right on this, so the black and red are going to positive and negative. And then right around the corner here, you're going to find the fan that goes to the blower. And make sure these are 100% going to positive and negative to negative. You can always use a sharp pin to pull the leads out of those connectors, and then you can swap them around. So that's a quick tip on those. Now I want to pause the video here so I can go ahead and tell you how these end stops get placed into here. You can see here the X, Y, and Z have 3 different plugs. When you connect these, you're only going to use the two rightmost pins from this perspective, and that's because the particular type of end stop that we're using only has 2 pins. This is a super tight fit here, but this is the last thing that we have to do. The next step after plugging this in is to push all the electronics into the back cover. And that was our last step. Now we have our test calibration cube printing, and we're on our way to using our 3D printer. Okay, so as you can see, we are just finishing up the very first calibration cube out of this printer. For the most part, all that we did was push the electronics in here and wrapped up everything by putting some filament in and loading some filament into here. Danny did a little bit of wire wrapping here, but other than that, everything we showed on the video on how to do the electronics portion. I'm not going to cover in these videos how to get your first calibration cube or test print. A lot of other videos out there that are available to take a look at that cover that in a lot of detail, but you have your own working 3D printer. Yeah, so it's a really great project for him, and I think that he's very happy as it's just finishing up now. We'll be able to take this home and start using it all by himself. So if you enjoyed this video, make sure you subscribe and give it a big thumbs up if you liked it, and leave Danny some comments of encouragement for some of the first prints that he should print with his brand new 3D printer. All right, so that's everything. Thanks again for watching this series, and we'll see you next time.